let me these are graphing problems, but I'm not going to do it because it's a graphing problem. Problem number 18, for example. Problem number 18 is f of x equals log to the base 3 of the cube root of x. The cube root of x. I'm going to write it this way because we're going to want to translate it first. This is the cube root of x. Because of property 3 over here, what you'd like to do is to write the cube root of x as an element raised to a power like this, because we get this simplification. So what I'd like to do is I'd like to write this as log to the base 3 of x to the 1/3, right? Because that fractional exponent represents the cube root. Then, the way you read this is log to the base 3 of x to the 1/3 is the power that you raise. Well, first of all, what is this equal to? 1/3 times log to the base 3 of x. Right? So, how is this graph that is log to the base 3 of the cube root of x, how is it related to the graph of log to the base 3 of x? Well, if this is a graph of y equals 3 to the x, and its reflection across the line y equals e to the x is the graph of log to the base 3 of x, right? When I reflect this across the line y equals x. And then, this one, log to the base 3 of the cube root of x, just takes the other one and multiplies it by a factor of 1/3. So, for example, here, log to the base 3 is 0. 1/3 times 0 is also 0. So that particular point is on the graph. Wherever this is equal to 1, it's multiplied by a factor of 1/3, so it's only 1/3 as high, right? Whatever this is, it's multiplied by a factor of 1/3, so this comes in, and it's 1/3 of this height. On this side, the same property is true. Whatever this distance is, it's multiplied by 1/3, which brings it in faster. It decreases. It brings it over to this curve. It doesn't decrease as fast, actually, or increase as fast on this side because the factor is 1/3. So if you take this particular curve and multiply it by this factor, this is the graph of log to the base 3 of the cube root of x. I was thinking I wasn't going to do this as a graphing problem, but it makes sense to do this as a graphing problem. Questions on that? Yes?
You're just multiplying the y value
by 1/3. So for example, log to the base 3 of x is 1 when x equals 3. So if I jump over here to x equals 3, this curve is up at 1. Because log to the base 3 of 3 is 1. This particular curve, log to the base 3 of the cube root of 3, then is 1/3 of that height, and this is supposed to represent it's only at 1/3 rather than at 1. So everything is scaled down by that factor of 1/3. Log to the base 3 of x squared, using the basic properties of logarithms. This is x raised to a power 2. This is the same thing as 2 times log to the base 3 of x. So we take log to the base 3 of x, which is this curve, and then it's multiplied by a factor of 2. And so at 3, where this is 1, this becomes 2 times 1, and so our other curve then moves us up 2 units. Down here, when log to the base 3, where it's minus 1, it's down at minus 2. It decreases more rapidly. This is 2 times log to the base 3 of x. Questions? Yes?
Could you do kind of like a T-chart where, because I'm getting confused, because I'm trying to put in like my x for just the match with the log base 3 to the x, and then I'm trying to put my x for log base 3, like 2 times log base 3 to the x. I'm getting confused.
By T-chart, you mean the values of x and then they... in order to compute, for example, what 1/3 log to the base 3 of x is?
Yeah, and like just 1 or 2.
Okay, sure. So, if this is x log to the base 3 of x log to the base 3 of the cube root of x, which we saw as the same thing as 1/3 log to the base 3 of x, right? So at x equals 1, log to the base 3 of 1 is the power which you raise 3 in order to get 1. This is 0. Since this is 0, this is 0, this is 1/3 times 0, so this is also 0. At x equals 3, log to the base 3 of x is 1, because it represents the power that you raise 3 in order to get 3. And since this is 1, that means this is 1/3. Log to the base 3 of 9, I'm making life easy on myself here, right? By looking only at powers of 3, then this is 2, and this is 1/3 times 2, which is 2/3. For x equals 1/3, let's go to the other side. For x equals 1/3, then log to the base 3 of 1/3 of 1/3 is, yes, log to the base 3 of 3 to the minus 1, which is minus 1. Right? And so this term is minus 1, and this term is 1/3 times minus 1, or minus 1/3. And then at 1/9, this is minus 2. This is 1/3 times minus 2, which is minus 2/3. So, if you were going to use this chart, this would tell you what to do with the negative values on this side, and this would tell you what to do with the positive values. You can see what it does is, looking at this graphically, if this represents log to the base 3, whatever this is, it's scaled by a factor of 1/3. Right? Anything else?
So you always want to pick your x values as powers of 3.
If I'm working with log to the base 3, then it's easy to recognize what the log to the base 3 is for a value which is 3 raised to some power. Because from this formula, log to the base 3 of 3 to the x is x. So if I can express a number in the form 3 to the x, then I can immediately read what its log to the base 3 is. Right? That's why choosing powers of 3, and these are powers of 3 also, of course. This is the power raised to the minus 1. This is the power raised to the minus 2. Make sense, Colleen?